All right, welcome to the 2018 question number 5 FRQ for AB Calculus. Let's get started. All right, so we're given let f be the function defined by f of x equals e to the x cosine of x. That's a product rule, might come in to play sometime down the road. Question A, find the average rate of change of f on the interval x is greater than or equal to 0, less than or equal to pi. So if you recall back in our foldable, this was early on, we have the formula for average rate of change. It's just the slope of the secant line, which is just f of b minus f of a over b minus a. So there's our a, and there's our b. So part A is going to be f of pi minus f of 0 over pi minus 0. Alright, so f of pi just means plug pi into our function, so we're going to have e to the pi cosine of pi minus e to the 0 cosine of 0 all over pi. The cosine of pi is negative 1. So we have negative e to the pi. The cosine of 0 is 1. E to the 0 is 1. So this is just minus 1 all over pi. There's our final answer. Average rate of change. All right, question B says, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2. So tangent means the slope, so we need to find f prime, and then we need to find f prime of 3 pi over 2. So like I said, we have a product rule here, e to the x cosine of x, okay? So f prime of x is going to be the second thing times derivative of the first, okay? So the derivative of e to the x is e to the x cosine x plus, and then it's going to be the first thing times the derivative of the second thing. The derivative of cosine is negative sine, so it's going to be actually a minus here, but I'll just write negative e to the x sine x. That's our derivative, okay? So we had second thing times the derivative of the first plus first thing times the derivative of the second, which is negative sine x. We want f prime of 3 pi over 2. So that's going to be e to the 3 pi over 2 cosine of 3 pi over 2 minus e to the 3 pi over 2 sine of 3 pi over 2. Alright, the cosine of 3 pi over 2 is 0. So 0 times this thing right here is just going to be 0 minus the sine of 3 pi over 2 is negative 1 times this is going to make it a positive because we have this negative here, positive e to the 3 pi over 2. There's our final answer. You don't need the 0, obviously, but e to the 3 pi over 2 is the slope of the line tangent at x equals 3 pi over 2. Alright, part C says find the absolute minimum. Absolute, hopefully you're already thinking EVT, which means we have an absolute minimum at an endpoint or any critical number in between the endpoints. Absolute minimum value of f on the interval 0 to 2 pi. Okay, so the first thing we need to do is we need to say where our critical numbers are, and our critical numbers are when f prime is equal to 0. Okay, so if you go back and you look up here, we have our derivative here, e to the x cosine x minus e to the x sine x. Okay, if you factor out the e to the x, you'll end up with e to the x times cosine x minus sine x. Okay, this will never be equal to 0. E to the x will never be 0. Okay, so we're just going to set cosine x minus sine x equal to 0, and that's the same thing as saying where is cosine equal to sine. Okay, because if you subtract them and get 0, that means they have to be equal. Well, where on the intervals 0 to 2 pi, there are two places where cosine and sine are equal. The first one is at pi over 4. Okay, the sine is radical 2 over 2, and the cosine is radical 2 over 2. And at 5 pi over 4, where they're both negative. Okay, so those are our two critical numbers. And our endpoints are 0 and 2 pi. So we're going to make a table. Okay, so you're going to have x here, you're going to have f of x here. And our numbers we're going to check are 0, pi over 4, 5 pi over 4, and 2 pi. Okay, we're plugging these back into f of x. Okay, so if we're looking for an absolute minimum. So if we plug 0 into this, the cosine of 0 is 1, e to the 0 is 1, so this whole thing will give us 1 here. Okay, if we plug in pi over 4, okay, the cosine of pi over 4 is radical 2 over 2, so that's e to the pi over 4 times radical 2 over 2. Now, this is a non-calculator question, so I think that's obviously probably bigger than that, right? Okay, but as far as actual values, we're not going to have to worry about that because it's going to most likely be pretty obvious which one's going to be a minimum, and if they asked for a max, it would have been obvious that way also. All right, so now let's plug in 5 pi over 4. The cosine of 5 pi over 4 is negative radical 2 over 2, and then this will be e to the 5 pi over 4, so you'll get negative e to the 5 pi over 4 times radical 2 over 2. Now, regardless of what that works out to be, it's definitely smaller than these two because it's negative. I bet you this one is probably going to be positive or 0 or something like that, but probably not negative. All right, so we're going to plug 2 pi in. The cosine of 2 pi is 0. Cosine of 2 pi is actually 1. Okay? And then we have e to the 2 pi. Why am I confused here? We have e to the 2 pi. That's right. Never mind. I'm not confused. Okay? So the cosine of 2 pi is 1, and then you have 1 times e to the 2 pi. You get e to the 2 pi. All right, so obviously this one right here is our minimum. So we're going to say absolute min by EVT on the interval 0 to 2 pi. Right here. Sorry about that little gaffe. We're good now. All right, question D. This graph obviously is coming into play finally. All right, let G be a differentiable function. Okay, when they say that, that's important. That's going to tell us something. Such that G of pi over 2 is equal to 0. The graph of G prime, the derivative of G, is shown below. Find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Justify your answer. Okay, now remember when we're doing limits, there's 3 things we can get. We can get 0 over a number, which is 0. We can get a number over 0, which means it does not exist. And we can get 0 over 0, which means we have to simplify or most likely use L'Hopital's rule, since we now know that. So let's start off with just breaking this up, and by finding the limit as x approaches pi over 2 of f of x, which means plug pi over 2 into f of x and hopefully you get a value. Okay, so the cosine of pi over 2 is 0, and 0 times anything is going to end up giving you 0. Okay, now since g is differentiable, it implies that it is continuous. Okay, so now the limit as x approaches pi over 2 of g of x, since it is differentiable and continuous, that has to be the same thing as g of pi over 2, and we're told that g of pi over 2 is 0. So the limit as x approaches pi over 2 of f of x over g of x is going to give me 0 over 0. And whenever I get 0 over 0, I need to do L'Hopital's rule. Okay, so I got to state that. By L'Hopital's rule, the limit as x approaches pi over 2 of f of x over g of x is equal to the limit as x approaches pi over 2 of f prime of x over g prime of x. Okay, so now that is our f prime function. Okay, remember we had f prime down here. Okay, although we found it at 3 pi over 2. This time we're going to find it at pi over 2. Okay, so we know that the cosine of pi over 2 is 0. So the whole thing becomes 0. Now we got the sine of pi over 2. So the sine of pi over 2 is 1 times negative e to the pi over 2. So that's going to give us negative e to the pi over 2 as the limit as x approaches pi over 2 of f prime of x over the limit as x approaches pi over 2 of g prime of x. Well, here is g prime, and as we approach pi over 2, from the left side we're approaching 2, from the right side we're approaching 2, so that gives us 2. So the limit as x approaches pi over 2 of f of x over g of x is negative e to the pi over 2 over 2. Final answer. Okay, I will post the rubric so you can look at the values of the points, and they also go through this thing for you. But there's an explanation of how to do each problem on the 2018 number 5.